discussion of the previous session where we left with a question. Find the solution of differential equation given to you by this, right? So if you see, if you say dy by dx in this particular case, if I write it down dy by dx, this will become minus of y cos x plus sin y plus y upon sin x plus x cos y plus x. Now when I'm saying that let us try to do the variable separable, I'm not able to do because there is x y term. If I say homogeneous, I'm not able to derive that particular thing because there are sin x cos x sort of terms. So let us try to make it in an exact equation format. Now if I'm trying to make it in an exact format, let us cross multiply. Cross multiply, we are saying it is sin x plus x cos y plus x times dy is equals to minus y cos x plus sin y plus y dx. Now let us rearrange this in form of m dx plus n dy. So we will bring this side, so it will become y cos x plus sin y plus y dx. This is m dx plus n dy. So n will become sin x plus x cos y plus x dy is equals to 0. So it is correlating with the standard form m dx plus n dy is equals to 0. So we need to check whether this equation is exact or not, right? So if this equation is exact, your fundamental del m by del y should be equal to del n by del x. So let us check it out whether this is happening or not. Let us first find out, let us first say what is m. M is nothing but y cos x plus sin y plus y, right? So del m by del y with respect to y, it will become what? Keeping x constant, so it is cos x plus cos y plus 1, right? Similarly, what is n? N is nothing but sin x plus x cos y plus x. So you have to solve dn by dx. So sin x will become cos x plus with respect to x we will keep y constant, that is cos y plus 1. So can I see that equation 1 and equation b are same? Yes. Can I say that del m by del y is equal to del n by del x? And this was condition of what? This was condition of a differential equation to be called as exact differential equation. Exact differential equation. So we can say that the equation is exact. So what is the solution now? Therefore the solution is we can easily now get the solution. Solution is nothing but integration keeping y as constant of m dx plus integration of terms in n not containing x plus c, or you can say equal to c, right? So first I will say m dx where y is constant. So integration with respect to x keeping y constant. So cos x will become sin x, y sin x, and the other term don't contain x, so will become 0. right? So it will become what? Integration of, you can say, y cos x plus sin y plus y dx plus in n, is there any term which is not containing x? No, there are all terms which are containing x, so there is no term at all. So this part will be 0, right? So this will be nothing but, very simply you can say, you have to keep y constant, right? So it will become y cos x integration will become sin x plus, you can say, sin y plus y times x, right, is equals to c. So that's your solution. So this is how you can solve the exact differential equation also. Clear? Let us take one more example on this. So the fundamental becomes very much clear and apt for us. Let us say the question is, find the solution of differential equation x square dy by dx is equals to x square plus xy plus y square. Now, can you make it variable separable? You won't be. Why? Because you can see you have xy term. So this won't be able to get separated, variable separable. Okay. Can you make homogeneous? Yes, you may try because the degree is same. Right? Let us take it out. So what I'm trying to say is dy by dx is nothing but x square plus xy plus y square upon x square. We have fx comma y upon gx comma y, and the degrees of f and y, g are same, which we discussed in our earlier discussions, right? So what we do normally in this is, you can see there is xy and x, so let us put y is equals to vx. So what will be dy by dx? It will be nothing but v plus x times dv by dx, right? So from 1, 2 and 3, from 1, 2 and 3, what we'll say is v plus x dv by dx, which is equal to dy by dx, will be nothing but equal to x square we can say x square plus xy plus y square, x square plus xy plus y square upon x square. So if I divide separately, what we'll get is v plus x dv by dx is equals to, this is 1 plus y by x plus y by x whole square. Or if you convert everything into x and v, then it will become nothing but 1 plus v square. So this v and this v gets cancels out. So we can separate it now, variable separable 1 plus v square is equals to dx upon x. If I integrate both sides, dv upon 1 plus v square is a direct integration of tan inverse v, very correct. Tan inverse v is equals to log x plus c. Now if you want to convert tan inverse of v, it can be written as tan inverse of y by x is equals to log of x plus c. In some books or in some options, sometimes it can be written as tan inverse of y by x is equal to log x c. Right? You know, if I see that, let's say this is c1, so basically c1 can be written as log c, isn't it? Which is constant. So log a plus log b will be log ab. So this can also be available in the options. So don't get confused with these particular areas. These are more or less the same thing. So we understood how to solve variable separable, homogeneous or exact equations. Right. Now we will move on to the next type of discussion that is called as linear equations. An important one. Many questions are being asked on this thing. Next heading we will take is linear equations or solution of linear equations, in fact we will say. So when a differential equation is said to be linear, it is important for us to understand that whenever the dependent variable, that is y in dy by dx, y, and its derivative occur in the first degree, and are not multiplied together. Then we say that the differential equation is a linear one. Right? What I'm trying to say is in a generalized form, you can say a standard form. A standard form of linear equation of first order is given as dy by dx plus py is equals to q, where p and q are functions of x only. This above equation is also referred as Leibniz equation, Leibniz linear equation. Important to note, this format is called as Leibniz linear equation. So sometime we will give you Leibniz linear equation, it's the same thing. It is not making any difference on that particular front. Right? Now the question arises how to solve this thing. This equation we have got, okay, this is a linear equation we got, right? So there need not to be a term which is multiplication of this. For example, if I have a term y divided by dx, no, this is not linear, non-linear, right? If I have term, let's say dy by dx into del square y by dx square, no, non-linear. Clear? right? If I have a term, let's say d del square y upon del x square plus y del y by del x, no, non-linear, right? The multiplication of dependent variable and its derivative is not allowed in linear equations. Clear? So this thing is very crystal clear, and question has been asked on this particular fundamental. I'll solve one or two for you later on, but this is a very important fundamental. Now the important part is how to solve. So let us take the next topic, that is solution of this linear equation. Solution of linear equation. We have seen that the linear equation is of the format dy by dx plus py is equals to q, right? So the solution of this equation is basically got when we multiply both sides by an factor which is called as the integrating factor, and the if or the integrating factor is given by e raised to integration of p dx. So the solution becomes dy by dx into e raised to integration of p dx plus y times e raised to integration of p dx into p is equals to q times e raised to integration of p dx. That will be the solution of this differential equation. So if we integrate on both sides, now on integrating both sides, we can directly get y e raised to integrating factor is equals to integration of q into integrating factor plus c. So this you can remember directly, but from where it is coming, we just said that integrating factor is a factor if we multiply this with the all terms of the given differential equation, it will give us the solution. Then we can easily integrate that particular thing actually. So this is how we can actually solve the differential equations, right, which are linear in nature. Important thing is linear in nature. You can also say, sir, sometimes equation can be of the format dx by dy plus px is equals to q. This is also linear equation. Linear equation. Here your integrating factor will become what? E raised to integration of p dy, right? And the solution of this differential equation will be nothing but x into, after integration I am talking about, e raised to integration of p dy is equal to integration of q into e raised to p dy plus c. So this also can be sometimes asked. Linear equations can be of dx by dy or dy by dx format. It depends, right? It depends. Let us solve one problem from the GATE paper. This problem basically appeared in GATE 2006. GATE 2006. The problem was something like the solution. of the differential equation dy by dx plus 2xy is equals to e raised to x to the power minus 2 with y0 is equals to 1. There are some initial condition given to you. Is the options were 1 plus x e raised to x square. Second, 1 plus x e raised to minus x square. Third, 1 minus x e raised to x square. And fourth, 1 minus x e raised to minus x square. Now try to understand, whenever you will see the options, it will be very much similar. Options in 90% cases will be symmetric, because most of the student will be able to detect that particular thing, but they will do some mistakes in minus plus powers multiplying. They have missed into 2, they have missed divided by 2. For example, in an options where options are like 12.5, 25, 50, 100. So the examiner knows that even if you get the answer, you may miss a factor of 2. You multiply by 2, you get this, multiply by 2, you get this, multiply by 2, you get this. So you would have mixed the factor 2, or you would have added an extra factor 2. For example, the answer was supposed to be 50. You miss the factor of 2, you will get answer B. You extra added one factor, that will give you 100. So this is how you get digressed. And once we get the answer in the paper, we do not cross check. That is a blunder in exam. That is what we do as a blunder in exams. We have to cross check. Unless and until you cross check, you will die. Because when you are targeting the top notch IITs or the PSUs, you will have to do that particular thing, right? So let us solve this question. We can see that this is a standard form of a linear equation. dy by dx plus py is equals to q. So dy by dx plus py is equals to q. So first we will find out the integrating factor. Integrating factor if is e raised to integration of p dy. Sorry, p dx, not dy, because it is in terms of x only. So p dx. So it will be nothing but if would be e raised to integration of 2x dx, which will be nothing but e raised to x square, isn't it? Yes, positive, right? Now we know the solution now. Therefore the solution will be, what will be the solution? Y into e raised to x square is equals to integration. What was q? And q was e raised to x raised e power x raised to minus 2 into integrating factor, that is e raised to x square plus c. So e raised to x square and e raised to x to the power minus 2 will become what? When you add this, it will become 1, right? So y e raised to x square integration would give you x plus c, isn't it? Now this is not the answer. You cannot see this in the options. Why? Because there was some initial condition which was given to you. So you actually have to find the value of c. What was the initial condition which was given to you? y0 is 1. That means from initial conditions, what we will get from initial conditions? We say y is equal to 1 when x is equal to 0. So substituting this in equation 1, what we'll get, we will get 1 e raised to 0 is equals to 0 plus c. So c becomes 1, right? Now again substituting this in 1, therefore from equation 1 we get what? Y e raised to x square is equals to x plus 1. Now directly this is also not available in the options, but if you see, you can rearrange this e raised to x to the power minus 2 into x plus 1. Is this available in the option? Yes, it is option number B. So your answer will become option B. Clear? So this is how we can actually solve such problems. So this is how you can find out exact equations and linear equations questions, right? Thank you.